Okay, so today we're going to be talking about two concepts. The first is polymorphism, um, and this is a really important concept in object-oriented programming. And the second concept we'll talk about is Dunder methods, aka magic methods. So polymorphism refers to, I think in Latin it actually means many-shaped. So it refers to the ability of a class to inherit from multiple other classes and to share methods and attributes with multiple parent classes. So let's come up with a class that's going to be the parent. Let's just call this the dad class. And we'll initialize this with method. I'm just going to say age equals and there's going to be a method, and it's just going to print hello there. We're going to have a mom class age let's do, instead of age, let's do name. And the speak for the mom class is going to be, how are you doing? And we're going to have a child class, and this is going to inherit both the dad and the mom methods and attributes. So let's call an initialization in the constructor, and we'll do age and name, and this is going to be self.age equals age, self.name equals name, and actually what we can do is instead of doing self, instead of redefining these like this, we can actually just, I believe we can just call the super super initialization function, and this actually takes in the age and the name because we're initializing the parent. We're initializing, we're acknowledging that this child class is inheriting these two constructor functions, and so by calling super, we call the parent classes, and we can pass in the appropriate variables to it that it'll take. And then we're also going to do a in school, and this is going to be set to true. Sorry, self.in school. And that will be set to true. Alright, so this is where this gets interesting. Let me just make sure this is going to run. Child1 equals child. And the age will be 15, and the name will be Jimbo. And then I should be able to do child1 dot speak. Before we do that, let me just make sure I can initialize this. I'm going to run it. Alright, it doesn't like that. Why didn't it like that? Alright, so what's going on is I'm using this improperly, and it's confused about it. So we're going to just rip this out for now. I'll cover it in another lesson. We're going to call these like we normally do. And let's run this again. All right, all that is good. Now, any guesses as to this is gonna, since it's a child, it's gonna inherit the methods from the dad and the mom. If I run child1.speak, any guesses as to what it's gonna do? Because mom says, "How are you doing?" and dad says, "Hello there, son." Let's go ahead and run this. Hello there, son. So it's inheriting the dad's, giving priority to it because dad was passed in first. So if I do this again, I put mom first. Let's run it. And it runs mom's. So that's pretty cool. And similarly with attributes, let's say dad has been lying about his age. It's actually 1.2 times whatever he says it is. So we are going to say with, let's say, def speak self for the child is, he's just going to say his name, print self.age, or let's say I am age years old, I am a child, and I am age years old. Alright, and then we're going to do speak. So any guesses as to what this child is going to speak? Is it going to be self.age? Is it going to be the mom's age? Oh, actually, we didn't give mom an age here, so let's go ahead and do age for mom. Is it going to be the mom's age that we're inheriting, or the dad's age? Let's go ahead and see. I'm a child now, I'm 15 years old. So, okay, so this is actually something worth pointing out, is that because we actually define this explicitly in the child, then the child is given priority, and it is going to be the value rather than anything that's inherited from the parents, because it's lower down and we're calling it directly. So it's just a little bit about the way that polymorphism works. Yeah, so I'm going to go ahead and close out this lesson. Just as a brief explainer to polymorphism, I'm going to close this out by talking about Dunder methods. Dunder refers to double underline, so that is these, init, and another one that is somewhat common is def str. So this is what happens if you run the built-in string function str on an instance of this object. We're going to return this. And let's say my name is self.name. We're going to pass in child1, and we're just going to see what this says. Oh, we need to print it, sorry. Cool. So as we can see, running the string function on the child one by overriding the str built-in dunder method enabled us to access this, just like the dunder initialization method allows us to tap into some functionality there. There are many dunder methods. Another really good one is print. We're going to print out, I believe it's IMO. Well, let me look at my work from today. MRO, that's it. So I believe it's child1 dot m MRO. So if we print this, what happens? Whoops. Whoops. Looks like I'm using it right. Method resolution order. So why isn't this working? Oh, we have to do it on the class directly. Child.mro. Awesome. So here we can see how methods that contradict overlap, or how they're executed. So this is the method resolution order. So first child is done. So speak is going to be using child's, but if there were no speak on here, then what happens? How are you doing? So now it's using the moms. And we can see that that is the MRO order, so the method resolution order. So first child is executed, but child has no speak, so instead it runs the moms. And if we got rid of moms, and run this again, hello there son. So that's dad's speak method. So as we can see, it starts with child, looks to see if there is a method. If there is none, it goes up the tree and executes this way. So that's a little bit about some dunder methods.